Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Batul. In today's video, I'll be talking about how to execute one-way analysis of variance using Microsoft Excel. Even before I proceed to demonstrate how one-way analysis of variance can be performed using Excel, my request you to subscribe to my channel, also like and share my videos. Let me begin by introducing you to the data set that I have. I've got 5 columns, as you can see. The very first column has the customer information. Then I've got 4 regions, namely Central Region, Eastern Region, Southern Region, and Western Region. The data involves the amount of money spent by the customer. For example, the first customer, Aaron, he's spending $1,476 in the Central Region, $65 in the Eastern Region, $771 in the Southern Region, and $737 in the Western Region. What are we interested in checking in ANOVA? In ANOVA, we are interested in checking whether the means for the 4 regions is identical or not. ANOVA primarily comes into picture when you're comparing 3 or more than 3 groups. If you have only 2 groups, you don't need ANOVA. You can go ahead and compare 2 groups using independent samples t-test. In our case, we have 4 different regions, namely Central, Eastern, Southern, and Western region. We are interested in finding out whether the average sales in each of these regions is the same or different. How do we execute ANOVA in Excel? To execute the one-way analysis of variance using Excel, I will click on the data menu in Excel. To the far right, you can see the option data analysis. Let me go ahead and click on this particular option. The very first option here is ANOVA for single factor. I'll hit the OK button. Excel asks me to specify the input range. The input range has already been chosen by my earlier selection. Further, if the data is grouped by columns or rows. In my case, the data is grouped by columns, so I'll choose the option columns. The first row, as you can clearly see, contains the labels, and therefore I'll select this particular option, that is labels, in the first row. There's one more interesting option, that is the alpha level. By default, Excel uses the alpha level of 0.05. You can change this to either 1% or 10%. So these are the 4 things that you need to keep in mind. Specify the range of the data. Please tell Excel whether the data is grouped by columns or rows. Thirdly, you have to check the option labels in the first row if your data contains the variable names, and specify the alpha level. Once you're ready with this, you can go ahead and hit the OK button. As you can see here, in a span of few seconds, Excel gives me the output for ANOVA. There are 2 tables that you can see. One is the summary table, and the second one is the ANOVA table. Let me just go ahead and expand this. It's easier to visualize now. As you can see here, ANOVA reports the summary for the 4 groups. It reports the count, the total spend for each of these regions, the average, as well as the variance. How do we interpret this? Customers spend the highest in Central Region. They spend on an average $1,275. In the Eastern Region, the average spend is $1,006. In the Southern Region, it is $724. And finally, in the Western Region, the average spend is $906. From this, we can conclude that on an average, customers spend the highest in Central Region and the lowest in the Southern Region. The question before us is whether these differences are statistically significant or insignificant. To answer this question, we look at the next table called as the ANOVA table. Here, when you look at the column, the first column is the source of variation. There are two different rows here. Between group variability, we also have within group variability. The second column that we have is the sum of squares. Nextly, we have degrees of freedom, and we also have the mean sum of squares. We have the F statistic, the P value, and the F critical value. Excel prints a lot of output. How do we interpret this particular table? Let me highlight some of the important numbers here. I'll be choosing the option sum of squares as well as degrees of freedom here. Let me go to home, choose the same color here. When we look at the first row, we have sum of squares. This tells me what is the between group sum of squares. The between group sum of squares is 38,12,124. You also have the degrees of freedom. When you divide the between group sum of squares by 3, you will be getting the mean sum of squares, which is 12,70,708. The same argument holds good even for within group sum of squares. When you divide the within group sum of squares by the respective degrees of freedom, what you get is the mean sum of squares. The mean sum of squares for within groups is 23,25,039. When you take the ratio of the mean sum of squares for between groups and the mean sum of squares for within groups, what you get is the F statistic value. The F statistic value here is 0.54. We can look at the P value to either reject or accept our hypothesis. What is the P value? P value stands for probability value. There is a simple thumb rule to interpret the P value. As you can see here, the P value is 0.65. We compare the P value with the alpha value of 0.05. Clearly, the P value of 0.65 is greater than 0.05. Since the P value is higher than the alpha value, we conclude by saying that we fail to reject the null hypothesis. I repeat, since the P value is bigger than the alpha value of 0.05, we conclude that we fail to reject the null hypothesis. And therefore, our final decision is there is no difference in the average spend of the customers across the 4 regions, namely Central, Eastern, Southern, and Western. So this is how ANOVA is very, very useful when you want to compare 3 or more than 3 groups. With this, I have come to the end of today's video. I thank you very much for watching this video. My request you to subscribe to my channel, also like and share my videos. Thank you very much. Have a great day.